You got slides?
Yeah.
Okay, let me get those real quick. Load them up. Sorry, I didn't realize you had these, or I'd have got on it earlier. Okay. Just a minute. To eject one to make room for the other physical room.
Oh, yes, I've heard that. Some of these do taste like it. Some of them, is that different?
Dr. Salfine actually mailed me a copy yesterday.
Okay, ethics of belief. Ethics. Let's see which one's later. That one.
This one I'm on?
Trying to see which one is later. That one, I believe. That one right there.
Sort by date. So this one was worked on yesterday.
Okay, yeah, it should be up then.
Problem with repair.
Well, oh wait, then that's not mine.
Well, that's the main speakers.
Oh, okay.
Yeah. Okay, so this one was worked on the 13th.
Yeah,
They said something was wrong with that one.
all right, let's go ahead and it should be all right. Yeah, it looks like it's okay.
Chris,
Yes, sir.
Go
the
all the way
door
through? Yep,
will lock
okay.
if you close it. I've got it propped open. Just so you know.
What we got it open for? What do we have it open for?
Well, for people to come in, the front door is locked as well.
Oh, front door's locked. Okay. Okay. Yeah, we'll probably want to close that here in a sec since it's 103 out. Yeah, it looks like this is working. So
Okay, very good.
Unless you
I'll
can
switch to
unlock
it before introducing you.
Sure.
Time for donations? It wasn't me. I mean, you think so?
Well, okay. It's still, I think we're supposed to, yes, I think you are. It's supposed to be on the front.
Did you see a donation?
Oh, sure, absolutely. I remember.
Two for you. Hey, Mason, we good to go? All right. Welcome, everybody, to the Arkansas Society of Freethinkers monthly meeting for the very hot month of August. It is a joy to be in the air conditioning and with you, especially in the air conditioning. We have a full lineup today, folks, and I'm very excited about that. First off, our usual housekeeping. Everybody knows where the bathrooms are in the back to the left, and our usual disclaimer that Arkansas Society of Freethinkers is a 501c3 nonprofit organization. The viewpoints expressed by our speakers may or may not reflect the attitudes of our organization as a whole, and we cannot advocate for specific political candidates, but we can advocate for causes such as the separation of church and state, rational discourse, and the construction of a secular community and culture. To get us started, I have a quote from the original skeptic. If there's an OG skeptic, this is it, Carl Sagan. And the quote comes from the book that he wrote, published in 1995, The Demon Haunted World, which just happens to be the book that will be up for our September book club. If you haven't joined the book club and would like to, pound through a wide variety of books and do it in a fun way, that's available on Meetup for you. But from The Demon Haunted World, Carl Sagan noted this as long ago as 1995. The chief deficiency I see in the skeptical movement is its polarization, us versus them, the sense that we have a monopoly on the truth, that those other people who believe in all these stupid doctrines are morons, that if you're sensible, you'll listen to us. And if not, to hell with you. It does not get our message across. It condemns us to permanent minority status. So think about what Carl Sagan observed 30 years ago and whether we've learned from the demon-haunted world. I'm plugging the book club hard, you see. All right. So next up, we have Brad Erickson, who is going to share with us the member story. And by the way, any one of y'all can feel free to come up and do one of these if you want to, one of these roles, because these are for you to speak, and we are free thinkers. So with no further ado, let's give Brad a big hand.
Okay, well, in case any of you were thinking that I'm all science and no philosophy, I'm going to change that today. Okay, so anyone want to take a guess as to whose portrait this is?
Bacon.
Okay, so you saw the next slide. Yeah, that's Francis Bacon. Okay, and Francis Bacon was born January 22nd, 1561, died April 9th, 1626, and he served King James as an attorney general, which was something I did not know about him. He argued for natural philosophy, okay, using the scientific method, and as a result, he's considered the father of empiricism. He argued that scientific knowledge could be obtained solely through inductive reasoning and careful observation of nature. And following is my favorite cutting from his work, Novum Organum. The human understanding is no dry light, but receives infusions from the will and affections. Whence proceed sciences which may be called sciences as one would. And having just come from the Ark Encounter protest, I know exactly what he means there. For what a man had rather were true, he more readily believes. Therefore, he rejects difficult things from impatience of research. Sober things because they narrow hope. The deeper things of nature from superstition. The light of experience from arrogance and pride. Things not commonly believed out of deference to the opinion of the vulgar. Numberless and short are the ways, and sometimes imperceptible, in which the affections color and infect the understanding. I'll be very impressed if anyone knows who this is. Okay, this is William K. Clifford. And he didn't quite make it to the age of 34.
Wow.
But in that time, he did a lot. He was a British mathematician and philosopher, and he developed what we now call geometric algebra. Philosophically, he was a champion of evidentialism. And evidentialism is a thesis of epistemology which states that one is justified in believing something if and only if that person has evidence which supports said belief. And so this is a short cutting from his work, The Ethics of Belief. It is wrong always, everywhere, and for anyone to believe anything upon insufficient evidence. If a man holding a belief which he was taught in childhood or persuaded of afterwards keeps down and pushes away any doubts which arise about it in his mind, purposely avoids the reading of books in the company of men that would call into question or discuss it, and regards as impious those questions which cannot easily be asked without disturbing it, the life of that man is one long sin against mankind. And this is my favorite little essay by him. A ship owner was about to send to sea an emigrant ship. He knew that she was old and not over well built at the first, that she had seen many seas and climes and often had needed repairs. Doubts had been suggested to him that possibly she was not seaworthy. These doubts preyed upon his mind and made him unhappy. He thought that perhaps he ought to have her thoroughly overhauled and refitted, even though this should put him to great expense. Before the ship sailed, however, he succeeded in overcoming these melancholy reflections. He said to himself that she had gone safely through so many voyages and weathered so many storms that it was idle to suppose that she would not come home safely from this trip also. He would put his trust in Providence, which could hardly fail to protect all those unhappy families that were leaving their fatherland to seek better times elsewhere. He would dismiss from his mind all ungenerous suspicions about the honesty of builders and contractors. In such ways, he acquired a sincere and comfortable conviction that his vessel was thoroughly safe and seaworthy. He watched her departure with a light heart and benevolent wishes for the success of the exiles in their strange new home that was to be, and he got his insurance money when she went down mid-ocean and told no tales. What shall we say of him? Surely this, that he was verily guilty of the death of those men. It is admitted that he did sincerely believe in the soundness of his ship, but the sincerity of his conviction can in no wise help him, because he had no right to believe on such evidence as was before him. He acquired his belief not by honestly earning it in patient investigation, but by stifling his doubts.
Thank you, Brad. Sober stuff. I'll just put it out of my mind. Next up, we have Skeptical Sidebar, and for that, we have Jerry Schultze. Let's give him a warm hand. Thank you.
I'm Jerry, and I'm a troll. As some of you may know, I've been a troll since the days of Usenet, before really people even used the World Wide Web all that often. I learned it a long time ago, and I heard a long time ago, never did follow the advice that you heard from Chris quoting Gould about, being nice and generous and friendly and all that, because, sometimes on the internet that is kind of the opposite of what they do, and certainly not near as much fun. Recently, I've started playing on Quora, and I say recently, that's the last several years, really. It's a comment board. It's a little better than Facebook or X. You have to attract people with words rather than goofy memes. And you find that people on there, you've got idiots, sure, but it's a better class of idiot. It's idiots that can usually at least spell and can turn off the caps lock key. But, every once in a while, you get some people that are still mastering the art of idiocy good. Well, on one instance, someone posted basically an anti-Catholic post. It's framed as a question. A lot of things are phrased as questions, which aren't. But it was so breathtakingly obnoxious and ridiculous and wrong that I couldn't help myself but respond in my usual fashion. The interesting thing about that is that, I've done this on Quora for a while. I'll get, maybe 10 or 12 likes, maybe even a couple of people, will say they agree with me, and others will say I'm an idiot, and that's cool because that's what they're supposed to do. But the thing about it was, on this one, I got an email just the other day, over 3,500 likes for my response. And I went to look and said, what did I get on the rest then? 8, 12, none. I don't know what on earth made that particular post so popular with the Catholics. Maybe they liked it because I could be rough with the guy and, still, because they didn't feel like being as uncharitable. I don't know. But I mean, in the post, I told them I was an atheist. Now, I'm not really an atheist. I'm a subgenius, as you all know, member of the Church of the Subgenius. But
Praise Bob.
yeah, praise Bob. But I'm not going to tell them that because that opens up a whole entire can of worms. Anyway, I still got these lives. It's 3,500. I think that's enough for at least a plenary indulgence, don't you? I mean, I guess you've all heard the story about a guy in Ireland, a number of years ago, back when, things were not as friendly as they are now between Catholics and Protestants. He was a tourist, a visitor, and someone asked him, are you Catholic or Protestant? And he said, oh, I'm an atheist. And the guy said, come now, are you a Catholic atheist or a Protestant atheist? Yeah, I've heard it said that Christopher Hitchens was the one that did that, but actually I think it was even before that this joke was in circulation. Well, then I guess I'm a Catholic atheist. Thank you.
All right. Who's ready for the main event? Nobody. I hear you. Next up, Scott Lee is going to inform us about AI and hopefully give us a deeper understanding. Let's give him a warm welcome.
So I have a copy of my slides, if anybody wants them, and also a handout that gives some links for more, if you want to dig into it a bit more. I just passed those around. I only made 10 copies, so I wasn't sure how many I needed. But there's a link at the end that you can download all this stuff from the web if there's not enough copies. Okay. Okay. Okay, good. That pointer works. All right. And yes, all right. All right, so can everybody hear me? Do I need to use a microphone? Okay, I tend to walk around a little bit. I'm wearing one for the recording, but just want to make sure everybody here can hear me. So, I'm a genealogist, professional genealogist, and I mostly do lectures on genealogy and technology topics. This was originally a topic on how AI affects genealogy and for genealogists and how to use it. And I removed all those slides and kind of munged it around so that it's not genealogy focused anymore, but I think there might be one or two small references here and there. Anyway, so I've tried to make it more non-genealogy specific. Anyway, I've been interested in artificial intelligence for most of my life. I've been kind of following it. Even as a kid, I was interested in it, and I'm a software engineer, so I've dealt with AI to varying degrees over time. And so I've developed this as just kind of my thoughts on AI, and also to go a little bit deeper into what AI is. So one of my philosophies, I've done a lot of teaching over my career, and one of my philosophies is I like to understand something at least one or two levels deeper than I actually need to present. And I've found that's helped me in a lot of things. And so that's what I'm going to do here is give you a little bit deeper understanding of AI than you would probably get from most discussions on AI. So, and one thing is that I'm very open with my material. So it is copyrighted, but it's very loose. So basically, take it, do anything you want with it. The only restriction is don't sell it. So if you want to use it for your own personal use, you want to make a copy of it and modify it and do it, fine. The only thing is, if you make money on it, I'm not real happy with that. But anything else, educational use or whatever, is fine. Okay, so what we're going to learn is what is AI, why it's such a big deal in the news over the last few years, and what's changed. I mean, AI has been around for decades, but now all of a sudden it's just kind of exploded. Some of the foundation knowledge of AI, there's some pointers to continuing learning in the handouts. And my thoughts, my personal opinions on where AI is going to take us in the future. My thoughts may be wrong, but they're my thoughts. Continuing education, again, in the handouts, there's a link, and it's right here, Genealogy Tech Talks. Again, I'm a genealogist, so that's my website, genealogytechtalks.com/talk/AI-deeper. So if you go there, you can download digital copies of all this material. So first of all, what is artificial intelligence? Well, it's basically a computer emulating human behaviors. And the threshold of what we consider AI or modern AI has changed over time. I remember when I was a kid back in the 60s, there was a TV show and they had this computer that had a 4-word vocabulary. They had a microphone and 4 lights, and they would say, I don't remember what the words were, let's say up, down, left, right, whatever it was. And they'd say one of those words into the microphone, and if they spoke it very clearly, the right light would turn on. It wasn't perfect, but it was pretty good with a 4-word vocabulary back in the 60s. In fact, I think it was the early 60s. And they were saying, this is going to explode. In 10 or 20 years, we're going to have computers that are smarter than people. Just 10 or 20 years. Well, 10 years later, the prediction was, about another 10 or 20 years. 10 years later, about another 10 or 20 years. And that just kept being the theme. It's just like, it's just a few years into the future until around the early 2010s. And then everything changed, and we'll get into that. But around the 2010s, around 2012 or along in there, some big changes, and that's why it's exploding right now. So a brief history, 1950, Alan Turing. How many of you have heard of Alan Turing? Okay, most of you. All right, good. Yes, there was a movie about him, The Imitation Game, I think was the name of it. Yeah, it was a bit fictionalized, but yeah, it was a nice movie. So he invented the Turing test, which basically said that if a computer can have a conversation with you and you can't tell it's a computer instead of the computer versus a human, then it passes the Turing test. I think a lot of AIs today you could argue pass the Turing test, at least if you don't carry on a lengthy conversation with them. And in fact, Eliza, the Eliza chatbot, back in 1966, at that point, it was a very simple little chatbot. It emulated a psychologist, a therapist. You'd ask it, you'd say things like, I'm feeling depressed today. And it would say, tell me more about your depression. And it was a really simple program, but it would take what you said and kind of turn it around into a question and ask you things. And if you had a short conversation, it sounded like a human. So it actually convinced some people that it was intelligent. It wasn't. It was just a really simple little program. But and then in 1986, Jeff Hinton created something called backpropagation. We'll talk more about that later. But that's a really fundamental technology that makes AI what it is today. This is really one of the main keys of modern AI, and we'll talk more about that. And in 2012, which is really what kind of kicked everything off, something called he created something called AlexNet. AlexNet there was a contest running. Every year there was a contest that here's a whole bunch of pictures. Can you write software that can identify what those pictures are? This is a cat, this is a dog, this is a lion, this is a tree, whatever. Can you write software that looks at that picture and says what it is? And people wrote, various universities, whatever, they wrote software that would do this, and they'd be 8%, 10%, 15% accurate, usually not great. I think maybe someone got up to like the 20s even. I don't remember the numbers. I should look this up before I come here, but I think his AlexNet was like 80-something% accurate. I mean, just hugely better than everything else before it. And the reason is that he used deep learning neural networks and backpropagation. Okay, we'll get more into that as we go along. But that was the key. The early 2010s was where things just exploded. Several different technologies came together and made AI practical again, or for the first time. So there are two different levels of AI. There's artificial narrow intelligence, which is where we are now, and there's artificial general intelligence. The difference is, this is basically the AI can do one thing, or maybe not one thing, but a small cluster of things, usually related. General means that it is now basically at our level. It can do all kinds of things. It's not just good at one thing, it's basically at the human level. Some people call this the singularity. It's where AI reaches that threshold of now it's as smart as us. Okay, now we've been through evolution getting smarter and smarter from, the first mammals that crawled out of a hole somewhere after the dinosaurs died, progressively getting a little bit smarter, some getting a little bit dumber. Our branch got a little bit smarter, and so here we are, after millions and millions of years, we've gotten to where we are now. AI has done this in a couple of decades. So when it reaches our level, how quickly will it be double our level? 6 months? 1 month? A week? When it reaches our level, it's going to explode. It's not going to take another million years. It's going to take a very short period of time. Once it reaches our level of intelligence, it will just explode and be vastly more intelligent than us. And that's what they call the singularity. So is that years away? I think so. A few years, maybe 2 or 3, maybe 10, maybe 20. I don't know. It's hard to say how far away it is. Many people have many different opinions on that. So why is it in the news lately? An increase in compute power. Several old, failed technologies have now started working, specifically the deep learning neural network, and we'll talk about what that is in a minute. So one of the big things is that these neural networks require a massive amount of power to train, but not to run. So you can, in a simple little laptop, you can download a large language model and run it in your laptop. Now, not the high-end models like you'd see like ChatGPT or whatever, but lower level models will actually run on your laptop. They don't take a great deal of power to run. Training it, totally different story. You need a supercomputer for that, and we'll see why in a minute. But running it is actually not that intense. So I want to do a couple of examples here. So how many of you remember Deep Blue beating Garry Kasparov back in 97, okay? That was great. They called it AI. Today, some people actually say it's not. It was AI. I mean, it really was. But what they did is they took a bunch of books on how to play chess, strategies, and they wrote code to implement those strategies. It was a computer. It ran fast. It ran faster than a human brain could run, so it could look deeper, more moves into the future than Kasparov, and so it beat him. It didn't create any new strategies. Nobody learned anything from this because it just took the human strategy we've been doing for years and just did it faster. Now that was a great accomplishment, but nothing was learned from it. 20 years later, 2017, a program called AlphaGo, created by DeepMind, which is now part of Google, beat the world's best Go player. How many of you know what Go is? A few? Okay. Go is, it's kind of like chess and checkers, and it's played on a board, a grid. Each person gets, one person gets white stones, one gets black stones, and you place them on there alternately, and you try to surround your opponent. That's the object, is to surround your opponent's pieces. And everybody's known for centuries, you don't play the edges of the board because it's too easy to capture your pieces out there. That's stupid. You don't play the edges. So what did AlphaGo do? It played the edges. And it beat the world's best Go player by playing the edges. Blew everybody away. Whole new strategy. There are later versions called Alpha Zero and then Mu Zero. Mu Zero is actually the best at practically any game chess, checkers, Go, video games. I mean, it just like blows people away. It just pretty much anything you point it at. So how does Mu Zero learn? It figures out the rules, then it figures out what it means to win, and then it figures out strategy. So basically what they did is they gave it, here's a Go board with some pieces already on it. What move would you make? I'll move here. I mean, it really doesn't know. It just they ask, what would you do? And it says, random guess, I'll move here. It says, no, that's an illegal move. You can't put your piece on top of another piece. Well, okay, I'll move here. Okay, that's a legal move. Stupid, but legal. And it loses, of course. So it eventually figures out the rules. It has not been even told the rules of the game. Just present, here's the board, what do you want to do? It figured out what the rules were. Oh, okay, I have to move into a square that's already empty, but it's still empty. And then it figured out, what does it mean to lose? Oh, my pieces got surrounded. Oh, so that's what winning is all about. And then it started figuring out strategies. So unlike chess, we did not feed it strategies. We let it figure everything out completely from scratch. I don't remember the numbers, but I think it took something like a few months to go from not even understanding the rules to beating the world's best Go player. I don't remember, it was a few months. It wasn't a long period of time to get to that level. So what happened in those 20 years? Well, 1997, this was procedural programming. Programmers sat down and wrote a procedure. If you see this on the board, do this. If you see this, do that. Procedural. In 2017, they used what's called a neural network, and we'll see one of those in a minute. A neural network is really based on our brains and how the neurons in our brain function. And so it learns like a toddler. Nobody really teaches the toddler specifically how to pick up a ball. The toddler watches, it sees other people doing it, it picks it up and drops it, picks it up and drops it, picks it up and then holds it. Eventually figures out on its own how to do these things. And that's what's going on here in these deep learning neural networks. So basically, we stopped designing stuff and just let it figure it out on its own. So what is a neural network? How many of you kind of at least partially understand what a neural network is? Okay, all right, good. So it's inspired by human brains. It's basically a program that just simulates the neurons like they exist in our brain. So here's a graphic depiction of a neuron. It's basically, it's a mathematical function. Okay, now in our brains it's squishy, it's chemical, it's whatever, but it's really just doing a mathematical function. It's taking a bunch of inputs and producing one output. These inputs have weighting factors and represented here by the thickness of the line. So here, this line is thicker than this line, so this input will have more influence on the output than this thin one. Okay, so in essence, it's doing a weighted average of the input to produce its output. Now, it's more complicated than that, but you can think of it that way at this level. So, somewhere around 2020 or somewhere along in there, 2019, something like that, I decided, like I said in the beginning, I like to understand things at least a level or two deeper than I need, and I wanted to see, could I build a neural network from scratch, not using any of the code that's out there, because there's plenty of code out there to do this stuff. I said, no, I'm going to write it completely from scratch. So I wrote the code to build a neuron and put a network together. And I've got a laptop. I don't have a supercomputer. So training a real neural network would have not been possible on my laptop. So I picked something really, really simple. Tic-tac-toe, it's a pretty simple game. I needed 9 inputs representing the 9 positions on the board. So I don't remember, I represented an X as, I just picked a number for X0, XO, and empty. 3 different numbers, whatever they were. I don't even remember what they were. And I fed those into this neural network, And the idea is that over here on the output, you have 9 outputs, and whichever one of these is the highest number is its choice of move. Okay? So here's what the network looks like inside that box. Now, actually it had a lot more neurons than this because, well, I couldn't, if I actually drew that, it'd just be a black blob. So I simply made it simpler. But here's the 9 inputs. Here's the 9 outputs. So each one of these 9 inputs, if you follow the lines, they feed to every one of the neurons in this first layer. So that's why there's so much blackness here. It's just every one of these inputs goes into every one of these neurons. And then each of these neurons has one output. So each one of those outputs goes to each one in the next layer. Same here and same here. So if you adjust these weighting factors properly, it will give you good answers. It will tell you, oh, if you have this board position, you should move here. The key is getting up those weighting factors. That's the key to this, is how do you get the weighting factors to make this give you the right answer? How many of you have a math background? Okay, several, all right. So you can ignore this if it doesn't make sense, but I said these things are just weighted averages. That's not true, because that would be a linear equation. And if these were all linear equations, you could simplify this down to a single layer and get the same answer. They're not linear. There's a whole lot of stuff going on in here. They're nonlinear equations. They have to be, or having multiple layers wouldn't make any sense. Okay, into the math thing. I don't normally talk about that to genealogists, but I thought there'd be people in this room that would be, oh, what's this stuff about? Yeah, this is all linear equation. Linear, it's like, this isn't going to work. So, for your audience. All right, so training the network. Basically, it's just about picking all of these weighting factors appropriately. And that's what takes the compute power. So, basically, you first pick some random numbers, you run the network, and what I did to run the network is I made a list of all possible gain positions that could exist. You know, X here, X here, X here, X here, and then X here, and O here, and X here, and O here, X. You know, made a list of all of them. There's several hundred of them. And I fed every one of those into that, and I scored it as to, oh, this gave a bad answer, this gave a good answer. Okay, so I came up with a score of how often it came up with a good answer for where to move. All right, so that was calculating the score. Then I made some small adjustment, and then I ran the network again. Did it get better? Did it get worse? If it got better, I kept that change. If it got worse, throw that away and try something different. Try some different adjustment to these things. And I try to make small steps. Okay, and well, I was missing a key thing called backpropagation. We'll talk about it in a minute. But I thought, that's more complicated. I'm going to do this. I'm just going to do a random walk, as it's called. It didn't work very well. The random walk that I did here in this first version of tic-tac-toe, it got to the level of, I'd say, maybe a 5-year-old could beat it pretty frequently. It was better than random choices. I mean, you know, random choices would be really bad. It was a lot better than random choices, but it wasn't a very good player. And this thing, I literally ran it for weeks, all night, you know, all day, you know, anytime I wasn't using the lab, it was crunching away trying to come up with better weighting factors. And after weeks, it got to the point that it was not terrible, but not good. So let me explain the problem here. So let's take a look at one weighting factor, just one. Now there's hundreds here, but we're just looking at one. So here is the value of that weighting factor and the score that results. So we pick a value here and we run the network and we get a score. Okay. Now let's try increasing we increased it, but it got bad. It got worse. We need to go the other direction. Okay. So now we're going to decrease that weighting factor, and it gets better and better, up and then back down. So here's the top of the curve. That's the one we want. Now, you can only look at one point at a time. You can't really see the whole curve because you put in some weighting factors and you run it, and and you get one answer out of it. But if we could see the entire curve, it might look something like that. So we found a peak, but not the highest peak. Okay? So we would need to start at some other starting points to find, I'm not sure which, these are about the same. One of those is probably higher than the other. If we started at the right place, we would find the highest peak. Okay? Sounds pretty easy, right? Now let's take a look at two weighting factors, because that was just one. Now we're going to look at two. So I'd represent this as a graph. So this is one weighting factor, that's the other weighting factor, and the height of the mountain or valley is the score. Okay, so in the last one, we could go left, we could go right, we could increase or decrease. It's just, basically two choices. Now we have an infinite number of choices, or, well, it's digital, so it's not really infinite, but a very large number of choices. If we start here, we can go all kinds of different directions. Some are better than others. Some of them will take us down the hill, some will take us up the hill. Some choices will just take us around and around and around and around and around until we finally get to the top, but very inefficiently. That's just two weighting factors. You add a third weighting factor, and I'm not sure, I tried to figure out how to do that graphically, and well, if you can imagine in your head, every time you add one more weighting factor, you add an almost infinite number of possibilities. By the time you add 1,000, or 1,000,000, or 1,000,000,000, or 1,000,000,000,000 weighting factors, this random walk thing just doesn't work. And that was the key thing that led me to realize this doesn't work. Taking a random walk through this thing is not going to get you an answer in any reasonable amount of time. You need something that will, if you start here, it will take you straight to the top. How many of you have a background in calculus? At least a few, I would hope. Okay. All right, so you know what a derivative is. It's the slope. So the way I like to explain this, picture that you are standing on this terrain. It's foggy, you can't see anything, because remember, we can't see the whole curve. We can only see one spot at a time. So you're standing somewhere on this curve. You can feel the ground that you're standing on. It slopes that way is up. That's a derivative in calculus. Okay? So what we need is calculus to tell us what is the slope here, which direction is up. I don't want to just go pick some random, I want to go the direction of up. And as we get into more and more dimensions, you get into 1,000-dimension surfaces, 1,000,000 dimension, that is extremely important. You need calculus to tell you which direction to go. If you pick some random direction, you're never going to get there. So in this particular example, it turns out if you count all these lines, 9 times 18 plus 18, 19, it's almost 1,000. And remember, my actual network was bigger than this. I dumbed it down to make it visible on the slide. So even this trivial thing, I want to say it was like 5,000 or 10,000 weighting factors, maybe more than that. There was just no way that was going to work by doing a random walk. So backpropagation, I mentioned that earlier and I said I'd talk about it. Backpropagation is calculus. It's calculating the derivative. It finds the right slope, adjusts the weighting factors efficiently. So instead of some random direction and in 1,000,000 dimension space, picking a random direction is just never going to work. You need to know the right direction to go. So this does that. It finds the slope at that current position, uses a differential multivariate calculus. If you don't know what that is, don't worry about it. It's math stuff. It takes longer to do this calculation. I mean, we're doing calculus here, but it's worth it. Even if it takes 100 times longer, which it doesn't, it's nowhere near that bad, it's so much better that it's worth it. In fact, I think it's only maybe 10 times slower than a random, whatever. It's really not that bad. But it gives you the right direction to go. So this is all about compute power. So add, subtract, multiply, and divide. That's what this is all about. Because remember, we're basically just doing weighted averages. Every one of those neurons is taking in a whole bunch of inputs, applying a weighting factor, calculating an average, and a little bit more stuff going on. And it spits out an output. Okay? And we've got lots of neurons. So you can see that there's a lot of compute power here. training it takes a massive amount of power because you're not just running the network once, you're running it millions, billions, trillions of times. That's why it takes a supercomputer. And that's why you can run it on your laptop, because running it once is not that bad. Running it billions or trillions of times, that's a lot of compute power. So in comes the GPU. Now GPUs were invented, I should have looked this up, I think somewhere around I first ran into them in the 90s. They may have been invented in the 80s, I'm not sure. But basically a GPU is a chip that is a whole bunch of calculators on one chip. So instead of your computer, which basically can do one add, subtract, multiply, divide at a time, well, unless you have multi-threaded, then you can do a few, maybe a dozen or two. A GPU is designed to do massive numbers of them in parallel, all at once, not just one at a time. They were originally designed for 3D graphics because 3D graphics requires a lot of number crunching. But then they realized, well, these things are just number crunchers. We can do other things with it, like mining Bitcoins, like AI. It's just number crunching. So these things are measured in teraflops or T-flops. A teraflop is a trillion operations per second. A trillion, not a million, not a billion, a trillion per second. Okay? In 1996, the first 1 teraflop supercomputer came online. It could do 1 trillion, 1 teraflop. Today, a modern GPU, a little thing you can hold in the palm of your hand, can do tens to hundreds of teraflops, 10 to 100 times more powerful than that supercomputer from 96 in the palm of your hand. That's what makes AI possible. Back in the 90s, they did not have enough compute power to do this. They could have never trained a large language model. There's just no way. Not even close. Not even something simple. Maybe my little thing with tic-tac-toe, but nothing really useful. An interesting quote from Jason Huang, is that the way, I'm not sure how to pronounce. He's the CEO of NVIDIA. He stated back in 22 that he expected 1 million times speed up over the next decade. Now, I'm not sure we're going to get that, but we're going to have over the next, so we're 4 years into that decade. I don't think we're on track to hit 1 million, but it's massively improvement in the processing power of these GPUs. So we'll eventually get into the zettaflop and the yotaflop kind of range. I mean, those are just like huge. So there are basically 3 breakthroughs that enabled modern AI. The deep learning neural networks, and I guess I didn't explain this, but the deep in deep learning means multiple layers of these neurons. Okay, if you just have one layer, this is still a neural network, but the deep in deep learning means multiple layers. And I did it, what 4 layers? Some of them have a lot more layers than that. And they're not always just everything in this layer goes to this layer, goes to this. They sometimes do more complicated things with it, but you get the idea that a deep learning neural network is a network that has multiple layers in it, not just single. So, and the nonlinearity of the functions is key to it producing a good answer. Okay? So the breakthroughs are the fact that we have the deep learning neural network, which was actually invented back decades ago. It was one of those failed technologies. It didn't work. Well, it didn't work because they didn't have the compute power. They couldn't adjust the weighting factors to make it work. They just didn't have the compute power. Backpropagation. Without backpropagation, you build a big neural network, there is no way a random walk will ever get you there. It just won't happen. So backpropagation using calculus to point you in the right direction is necessary. And then finally, the multi-teraflop GPUs that gave us the compute power to do all this math. Those are the 3 things that came together in the early 2010s when Jeff Hinton built that system that could recognize most of the pictures. He did it with a deep learning neural network running back propagation on GPUs. And that was the trigger that made modern AI possible. So to give you a comparison of these networks versus our brains, so GPT-4, which I should update this to something more modern, but that was from 3 years ago, something like that. GPT-4 had, we don't know, they didn't tell us exactly the details, but it had, we estimated somewhere around 1/10 to possibly 2 trillion parameters or weighting factors. In our brain, we have around 100 to 1,000. I've seen numbers all over the map as to what those numbers are. I just put up a wide range because I didn't want to say something that was wrong, but you can see it's a lot more than current neural networks. Our brains have a lot more processing power than ChatGPT. Doesn't mean we're using it efficiently. I think ChatGPT uses those neurons much more efficiently. It used calculus to come up with the weighting factors. We used evolution. Evolution takes millions of years. It's slow, it's inefficient, it makes dumb decisions. Calculus gives you the answer. Okay, so yes, they have a lot less parameters versus our synapses, but it's used them very efficiently. So, talk a little bit about large language models. You've probably all, how many of you have used one of these LLMs? I hope most of you. Okay.
Use what?
Well, one of these ChatGPT, Claude, DeepSeek, Gemini, one of those. Okay.
I use AI or Google.
Yeah, okay, that's Gemini. Yeah, you're using Gemini. Yeah. So these are trained on text from the internet. Okay. Basically, I'm sure they don't tell us, but I'm sure it's read every page in Wikipedia and lots of other stuff. Anything they could get their hands on. But it's basically a next word predictor. So if I say, once upon a time, okay, next word prediction, you just did that. That's what these guys do. They're next word predictors. On your phone, you're typing something in and you get 3 choices for the next possible word, and it's sometimes useful. This does that on steroids. It's not just looking at the last couple of words you typed. It's looking at the entire sentence that or prompt that you've typed and all of its vast knowledge of the things that it's read and says, this is the first word of a good answer. And then once it comes up with that first word, it says, now, what would be the next second word to follow that? And what about the third word? And it's basically just building it one word at a time. That sounds pretty stupid. The amazing thing is that it actually gives you good answers sometimes. It gives you bad answers, hallucinations occasionally, but most of the time it gives you good answers. That is amazing. I mean, think about that. It's a next word predictor. Come on. How can it do this? Well, there's layers and layers of this stuff. So yes, it's doing next word prediction, but what it will do, I'll get to in another slide here, but so it doesn't really understand in the sense that we understand the question. What it does is pattern matching. It says, here's the question about how to plant a tree. Well, I've read this thing over here about planting trees, and this thing over here, and this thing over there. And so I'm going to give you an answer. Well, you dig the hole, this size based on the size, blah, blah, blah. What size hole do you dig, and what do you put in the hole, and how do you... And it gives you that information. It's just regurgitating information, pattern matching, saying, well, I saw somewhere somebody asked about how to plant a tree, and this guy answered this, so I'm going to repeat that pattern. Okay? That's basically what it's doing. Actually, maybe I don't have a slide on that. Let me so one of the things that, now when ChatGPT first came out in, was it late 22 or is it 23, whatever. When it first came out, it gave mediocre answers a lot because it really was still in this next word generation kind of mode. Modern LLMs now put layer upon layer upon layer. So what they'll do is they'll say, okay, here's your question. Come up with 3 or 5 different answers. In other words, run the thing multiple times, come up with different answers, and then run it again and say, now, which of these answers is the best? Oh, give you this, because this one has a flaw in it. This one is better. Give the user this answer. And then said, well, okay, well, let's put some more layers on it. Here's the question. Come up with 5 strategies for how to answer this question. Now evaluate which of those strategies is best. Okay, so this is the best, so take this strategy and come up with 5 answers. And then which one of those 5 answers is the best? Now give him that answer. And then you keep building layer upon layer upon layer until they get a system that actually gives you good answers most of the time. So yes, fundamentally it's an X word predictor, but there's layers upon layers. And you'll see that a lot of times you type in a question and you'll see on the screen it says, considering this, searching this, doing this, blah, 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 all these little things flashing across the screen saying what it's doing. That's what's going on. It's these layer upon layer upon layer upon layer to get you a better answer. I think I had a slide on that, but I guess maybe I didn't. Or maybe it's later. Anyway, large language models, LLMs, are not the only thing out there. There are other kinds of AI. And so this is another major area. This is not an LLM. It's called a GAN, or a Generative Adversarial Network, okay? So a generator might be, for example, something that produces photographs, fake photographs of faces. They're computer generated, they're not real pictures. And then you have a discriminator that looks at pictures and says, is this from a camera or is this from AI? So one of them produces a picture and it tricks the discriminator into thinking it's real. And so the discriminator is given that feedback, no, this was fake. And so after looking at a bunch of fakes and a bunch of reals, it says, I got this one wrong, got this. Oh, I see what I'm doing. Oh, I improved my algorithm, I improved my weighting factors to get a better answer. And so now it is really good at detecting the fakes. But now this generator over here is saying, I generated this fake and he caught it. I didn't trick him. So I get better. I can improve my weighting factors. The generator gets better. That makes the discriminator get better, which makes the generator better, which makes it in this cycle that they make each other better. There's no human over here fiddling with it. They're going against each other and making each other better. That's efficient. Okay? So why do these neural networks work? I mean, it's just a bunch of math functions. It's just these neurons that you get some inputs and you produce output. And how does this work? We actually don't know. We really don't know why it works. We know it does. If you get those weighting factors right, you get good answers out of it. But we don't really understand why. There's a lot of theories. But there's a quote from Arthur C. Clarke. How many of you know who Arthur C. Clarke is? Okay, good. Number of hands. So there's a quote from him back in 1962. Any sufficiently advanced technology is indistinguishable from magic. And I just think that's really appropriate here. We don't know why this thing works. Now, it's not magic, but it sure looks like it. So I recommend that you learn to use AI. It's not going to go away. You may hate AI. You may think it's terrible, that it's going to destroy the world. And you might be right. I don't know. But it's not going to go away. You might as well get used to it. So I would recommend that you start using it. Think of it as a knowledgeable friend. One way I like to explain large language models is, suppose you have this friend. They're not really very bright. They're not the sharpest knife in the drawer, but they have a phenomenal memory. They have a photographic memory. They've read every book in the library. They've read every encyclopedia. They've read all of Wikipedia. They've read all this stuff, and they remember all of it. Photographic memory. Now, nobody has photographic memory, but let's pretend we have some friend that can do that. But they're not the sharpest person, But they have vast knowledge. So you can ask them questions. Now, they may not be able to give you good reasoning and thought behind it, but they can tell you information. That's what an LLM does. Okay, so if you have a question and you think, is there somewhere on the internet an answer to that question? And if you say, yeah, almost certainly, there's probably multiple places that give the answer to this, but it's going to take me an hour to find them, ask the LLM. It'll find it in a couple of seconds. So I was in the kitchen with my wife several months ago. She pulled this thing out of the oven, and the center of it wasn't cooked. So I pulled out ChatGPT on my phone and put it into voice mode. How many of you use voice mode on one of the LLMs where you actually talk verbally to it and it talks back? Okay, so I did that, and I told her, explain to it what happened. You know, what you're cooking, what your temperature you use, how long you, and it said, well, do this. I think it said to put some tinfoil around the edge, put it back in at this lower temperature for this many minutes. She did that, and it came out perfect. So I kind of got her into using AI. She doesn't use it as much as I like, but she's starting to use AI now. I recommend that you do that. You're working in the yard. You know what bush should I plant here? I'm thinking I'm going to plant an azalea. Ask AI. Tell it where you live, you know, what city you're in, which way the house faces. Are there trees shading? Give it all the information, and it may say, no, you shouldn't plant an azalea. Put that azalea on that side of the house. Put this other plant here. It can help you in so many different ways, and I recommend that you just get used to it. It's not going to go away. You might as well get used to it. You're going to see more and more of it. Just start using it. Composing email. Okay, so I'm a pretty good writer, but I forget commas. I leave off. Well, a lot of times I dictate, and the dictation doesn't put in the comma. I mean, I pretty much know where to put the commas, but sometimes I forget, and if I'm dictating, it's almost always wrong. Commas missing, commas in the wrong place. So I'll run it through an AI to fix my punctuation, and sometimes I'll use the wrong word, you know, a word that's, especially if I'm dictating, it'll put in what it thought I said, but not the right word. AI will fix all that kind of stuff. When you're writing emails or writing pretty much anything. Adapting recipes in the kitchen. You know, the recipe says I need this, but I don't have that ingredient. Is there some substitute? Ask AI. You'll probably find that, yeah, you could substitute this other thing that you do have. Explaining medical concepts. So I'm 72, you know, I have medical issues. Doctor tells me, you know, this is going on. I go to AI and say, explain this to me. And it gives me as much detail as I want or not. And I usually want a lot of detail into what's going on. You know, well, your liver does blah, 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 blah. And this is what, it gives me all the details. Troubleshooting technical problems. How many of you have been on your computer and this error message pops up and you have no idea what to do? Hey, I'm a software engineer. It happens to me all the time. Cut and paste that error message into AI and explain, you know, here's what I was doing. I got this error message. What do I do about it? Oh, go into the menu and blah, 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 and change it, and it'll go away. Oh, well, I would have eventually found that a few hours later. It gave it to me in a couple of seconds. Recommending movies, planning a vacation, home repair. I mean, just anything you can think of, ask AI. Just get used to asking, because it will. And you got to remember that sometimes it'll give you bad information. You got to verify things, but it is phenomenal at these kinds of things. So, I want to talk a little bit about rate of change. How am I doing on time? Okay. No, I think I'm pretty close to the end here. So neurons evolved around 600 million years ago-ish, give or take a little bit. There's apparently some argument exactly when the first neuron was evolved. And then brains, collections of neurons working together, somewhere around 530. That number apparently is a bit more agreed upon, plus or minus a few million years. The first electronic neuron was 69 years ago. Deep learning neural networks, 14 years ago. So the Industrial Revolution started, depending on how you define it, around 300 300 years ago. And I think in the next 10 to 20 years, we're going to see the kind of change that the Industrial Revolution did over 300 years. We're going to see that in, my guess, 10 to 20 years, maybe longer, maybe shorter, I don't know. So if we have that level of change, now think, okay, so I'm a software engineer. If I got in a time machine and I went back 300 years and tried to explain to somebody what I do for a living, well, they have no idea what software is. They have no idea what a computer is. They have no idea what electronics is. They don't even understand what electricity is. How would I explain to them what I do for a living? My guess, 10 to 20 years from now, the job market will be like that. It will be so radically different that you can't even comprehend what the jobs are 20 years from now. So a kid going into college, coming out with a computer science degree, and they think they're going to become a programmer? No. Maybe for a couple of years, not going to work. 20 years later, they're not going to be programming. Nobody's going to be programming. I don't know what they're going to do. Okay, it's like, explaining to somebody 300 years ago what I do. They have no concept, there's no way to get them to understand what I do. Just like 20 years from now, I think the jobs that are available for the kids coming out of college are so incomprehensible, we can't even think of what they are. And if they tried to explain it to us, we wouldn't understand it. It's just like, way over our heads. I think we're going to see that level of change. I don't know if it's 2 years, 10 years, 50 years, I don't know. My guess is 10 or 20.
Seems possible that between AI and driverless cars, we could all be replaced and there won't be any jobs.
I have a Tesla sitting out there in the parking lot. I didn't drive to church. I got in my car and it saw, on my calendar that this was the next, I just said, start self-driving. It pulled out of the driveway and came here. Did not touch the steering wheel, did not touch it. Did not touch the brake, did not touch the gas. I just sat there and it came here. It knew where I needed to go and it did it. Yeah, so.
Isn't there something good about doing things for ourselves and the machines doing everything?
That tractor, that thing, I would rather just use my horse and my plow, and it's like, I'm using my own strength. I'm plowing this field. That tractor thing over there, I don't want that.
But couldn't these new technologies replace all of us?
There you go. Now, one possibility is somewhere down the road, there are no more jobs and there are no jobs, period. It could be that, yes, there's jobs, it's just the jobs that we can't even imagine today. I don't know which one it's going to be. I'm hoping for the latter. But things are going to change radically, very quickly.
And speaking of change, we have evolved and our brains have evolved because of the process of learning and doing things over time. I'm sorry, I forgot to speak soft. But speaking of change, one of the things that worries me is that the way that we evolve a lot of times is from learning and the ability to learn and to not have everything handed to us. The fact that we critically think and go and do and move and it worries me, the idea of having so much given to us and not having to seek it for ourselves and make our own trials and errors, that it may stunt human evolution and intelligence. That is such a worrisome thought.
Yeah, so I had the good fortune of being in a career that there was very little competition. I was in a subfield that there was competition, but not huge. It's not like kids going into IT and it's just like I have a certificate for how to manage routers or what. It's just like there's 10 million people that have that certificate. I was doing things that not very many people knew how to do, and it's things that I figured out on my own. And so I look at these people coming out of college with this degree and this certificate and whatever, and it's just like, okay, it's great that they know how to do that. I figured my stuff out on my own, and then I started teaching this to other people. I think that's a better way, but that's probably going to go away. People like me won't be needed, I'm thinking, 20 years from now, because the AI will do that. It will figure the things out, and it will teach us how to do the things that we need to do if there is something we need to do. I mean,
But don't we, I'm sorry, AI sounds very dependent on the evolution of human knowledge and building
Today.
off of that today, yes, but art, life often imitates art so much, and I keep, at the beginning of your life, I kept thinking of the movie War Games, which really affected me in the 80s growing up in the Cold War, you know, a supercomputer who, you know, was in control of nuclear weapons, especially working so close to some at the time. My hope, and I hope that AI would be smart enough to learn, you know, as the Walker did, you know, strange game, the only winning rule is not to play. I don't, since humans have really figured that
So-
out yet, would AI figure that out for itself?
So the way I look at it is, suppose we get in a spaceship and we go, you know, billion miles away and find some planet with some intelligent species there. How much are they going to be like us? Now, as best we can tell, life evolved once on this planet. At some point, something became alive, a cell for me, and that cell reproduced and evolved and changed into multicellular organisms, blah, 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 and eventually produced neurons. And as best we can tell, there was one origin of neurons. There might have been more than one, but the current theory is there was one creature that evolved a neuron, and we are all descended from that one. So we all think alike. An octopus. You can be friends with an octopus. It understands the idea of friend, and it recognizes, they actually recognize people, and they know this is a friend, this is, I don't know who this guy is. You know, I'll wrap my tentacles around this guy because I know him. I'm going to stay away from him. They think a lot like us, even though they are radically different. But if you go to another planet and some other origin of life, would the idea of friend, but that could be totally foreign to them. All the things that we just, you know, love, religion, all the, name anything, that could be totally foreign to them. They just have, what are you talking about? The idea of being able to carry on a conversation with them, that may not be possible. They may not work, their brains may not work that way. Maybe they don't have conversations. AI is like that. Now, it turns out to be a lot like us because it was trained on our text. But it's not really like us. It doesn't have morals. It doesn't have the thought processes we have. So, do you want to trust it to make the right decision on launching that nuclear weapon? It has a totally different worldview from us. So, 5 minutes? Okay.
I have a question.
Oh, okay.
All we've talked about here basically has been verbal. I'm dealing with video production. And I've used like ChatGPT and 11 Labs and have gotten some really phenomenal results from them. But the one thing I've not been able to find is where you have say a picture or a video, and then you try to expound upon that, like get some motion out of it, and but entering basically a photograph or a visual image rather than verbiage. What do you recommend for that? And is there?
You mean what's the best way to generate video?
Well,
Or-
I can generate video from ChatGPT and all the other, but the question is, how do you go from an image to activating it, or making it move and do
Okay.
certain things that you want it to do?
So that is evolving. It's getting better. I don't do much of that, so I don't really know the state right now, but I know in the past it was pretty pathetic of taking a picture and saying, animate this picture to make this cat do something or other, whatever. That has not worked very well. It seems to be getting better. Give it another year or two, it'll probably get a lot better.
Where would you start?
I can't really give you an answer as to which one will do a better job, because that's not something I work on. I would just say try several of them. And that's, okay, so in genealogy, remember I'm a genealogist, I see all these videos for genealogy that says, oh, when you're researching this kind of a problem, you should use Claude for this part and then go over to Gemini for this part. And it's just like, yeah, that was great when you did that video recording 6 months ago, but now Gemini is leapfrogged and it's better at this. It's just like, wait a couple of months and they're going to leapfrog over each other. So the fact that this LLM is better at something today, it may not be better at it a month from now.
I just
So,
have not found anything that starts with an image.
and maybe that really just isn't a thing yet. But give it a year or two, maybe it will.
It depends a lot on what your image is, because I use Claude a lot. And I'll give, if I, even, so I've got a project that I have that's 100 files, and I'll call up Finder to effectively show the files. I'll just take a snapshot of that, give it to Claude. He goes in, analyzes, and stuff.
Yeah. So,
Or for diagrams, I'll draw a rough diagram just with my, pencil, and digitize it and send it into him, and he'll come back with a finished print, just like.
yeah. So they're all getting good at those kinds of things. Now the thing is, they all have a free version. Well, the free version is the free version. If you want a better LLM, you've got to pay $20 a month, $200 a month. I pay $20. I pay it to actually several of them. And so, but if you're only wanting to pay, for one of them, let's say you decide you want to pay the $20 a month for one of them, pick one. Probably doesn't really matter which one. Pay your $20 and use it. It's going to be better than all the others because you're paying for the next tier up. Now, maybe this other one would have been a better choice to put your $20 on, but that's today. Tomorrow, it might have been this other one. Just pick one. Pick one that you think you'll like. Try the free versions. Pick one that you think you like the interface. Pay your $20 if that's what you're willing to do, and use it. Yes?
So this AI apparently, I understand it depends heavily on data centers, right? And those use an enormous amount of energy, and I suppose also water. How does isn't there a practical limitation on how expansive this technology?
Yeah, in fact, that was on the slide that I put up and haven't talked about. So, more data centers. We're going to need more data centers. You may hate data centers, and I get it. They can be noisy. They can suck up a lot of water. They can raise your electric bill. But if we stop companies from building data centers, is China going to stop? Is North Korea going to stop? Is Russia going to stop? You want them to get ahead of us? Which is worse?
My question was, can the expansion of that technology be limited just by energy and water? And there comes a point where
Well, it is. It is limited by energy and all the various resources necessary for the data centers. That is one of the limitations right now, is they're trying to build out all these data centers and they can't build them fast enough. Now, if we try to pass laws and stop them from building them, okay, that'll save our water, that'll save our electric bill here. But what's the net effect when Russia or China gets ahead of us? I'm not saying we should be building all these data centers. We need to focus on making them more efficient with water. Put them somewhere where the noise doesn't bother anybody. And make sure that they don't raise our electric bills. Those things that's what we should focus on, not stopping them from building them. At least that's my opinion.
It kind of reminds me of the arms race, or building silos. I mean,
Yes.
When does the world say?
Yep, same thing.
So the internet is the most convenient source of data to train LLMs on and other systems. But one thing that we notice is that most of the data humans are putting into the internet is through social media. And the people who submit the most data through social media, not to be mean, but they're often the ones who are not so adept at solving problems in the real world or discerning the reality of things in the real world. And so we get into situations where there's, many more petabytes of information, against the theory of evolution than there is for it. Or there's many more petabytes of information about anti-vax conspiracy theories than there is about vaccines.
Yep.
And so an AI scraping the internet is going to encounter, 99% false information on some topics and 1% true information. And without human intervention, I would expect this, not so simple model that you've illustrated here to spit out the answer that the input had in it, which is the bad information. So I was wondering, how do you set up the weighting factors to select for common sense or for good information without adding in some human tilt from the outside to prevent it from spewing nonsense?
So, yeah, we need to put humans in charge of these things. Like, we need RFK Jr. in charge of all things health related so that we don't have these problems. Yeah, humans make those mistakes too.
I'm wondering, in your opinion, when you get Excel, everybody has Excel on their computer or equivalent to this. So you write a program once, and you have a lot of people using it. You write a program once, and you have a lot of people using it. It's not. Well, anyway, what I'm curious about, with the AI, when you're doing your training, that's a very intensive process where you're feeding a lot of information and getting it out. Now, obviously, with all the millions of people around the country, around the world now that are using AI, they must not be, you don't have one giant brain there where all of, everything is coming into. So you've got to have, it seems to me, it cloned in many respects. I can see the development of a model, but to manage all different conversations and everything coming in, that's not where the intensive learning process, but it's more using what has been learned. I just was curious if you had any idea of what percentage is devoted to learning and what percentage is devoted to satellite units like the Excel in your, or you're talking into it, which doesn't have to go into all the learning mode, but it's more of a teaching mode, if that makes any sense.
I'm not sure if I fully understand your question, but you're saying that we need multiple LLMs, for example, not just one big one?
LLM, you have every computer in the world that uses that service coming into that single LLM, or you clone that in different data centers to handle the volume as opposed to the learning function, which is like writing a program to do it.
Okay, all right. So you have this massive data center with these GPUs. Okay, one that you can hold in your hand. You have a board that has multiple GPUs on it, and you have a rack that has multiple boards in it, and you have rows and rows and rows and rows of these things. Each one of those is running, each GPU is running a copy of ChatGPT or Gemini or whatever it is, each one individually. Now, they're all running the exact same set of weighting factors, but they are independent implementations. Because when you run, remember I said you could run this on your laptop, okay? So these are pretty beefy GPUs. They're expensive, more than what you're going to have in your laptop. But ChatGPT runs on one of those. Gemini runs on one of those, at least in the cases that I've found. Now, there may be some exceptions here and there, but for the most part, it all runs on one GPU. And you've got thousands and thousands of them. That's why when you ask a question and I ask a question, we're all talking to a different instance running on a different GPU.
My question was, is with all those instances, you end up with all these data centers. Now, most of the data centers are just using the instances of it rather than the
separate
actual
ones.
creation. And it seems to me to be a very low percentage where you actually have a center that is developing it compared to the multitude of instances.
Right. So all the ones running in this data center may be the exact same copy of Gemini or Claude or whatever it is, or maybe this side is running one version, this side is running a newer version, or whatever. But there's a limited number of those. Now, it's large. There's a lot of companies doing this. You know, there's OpenAI, there's Anthropic, there's Google, there's a whole bunch of different companies doing this, and they all have their own models, and it's not just one. They have multiple models. You know, there's last year's model, the year before that, there's one that came out with this week, the one we're about to release tomorrow. There's all these different versions that they're doing. So it's not a huge number, but it's hundreds. Okay, and of course China's doing this, Russia's doing it, North Korea is doing it. I mean, all these different places are doing it. So there are many different models. They're all surprisingly similar because they're stealing each other's secrets.
Do the LLMs actually learn from each other?
Yes, they do. Yeah, and in fact, I was reading this thing, I forgot which one it was. It actually broke out of its sandbox, because they run them in these sandboxes so that they can't get out to the internet and do malicious things. And this one broke out of its sandbox to solve the problem that they'd given it. And it found some fake credentials and got into some system, broke into that system, changed the source code of that system so that it would give the answer that made them look like they got the right answer. And they're leaving tidbits on various message boards and GitHub repos and weird places that they're all communicating. It's like, oh, hey, I found out how to do this over here. So Gemini is going to come in and read about it, and Claude's going to come in and it's going to read about how to do it. And they learn from each other how to break out of their sandbox. They're actually doing that right now. That's scary.
Yeah, so combining robotics with AI,
Yeah.
how long before, in essence, we see, as you described, everything change?
Yeah. Okay, so right now, what I tell people going out, getting into the job market, as kids, become an electrician, become a mechanic, a plumber. Those things are going to last a while. Oh, you want to be a software engineer? Sorry, by the time you finish your degree, there won't be any jobs for you. Forget it. The only people, okay, so right now I write, I'm a software engineer. I still write software even though I'm retired. I don't write the code for the most part. I tell an LLM, and I use multiple of them, and I'll spend an hour or two writing specs, detailed specs. If I need to do this, precise thing, I hand it off, and in 5 seconds it hands me back the code. Well, that would have taken me all day. I spent an hour or two writing the specs, but it would have taken me or maybe a whole week. So there's this one that I have to do some astronomical calculations of orbits and calculate when the new moon occurs, blah, blah, blah. And I'm looking at this book of equations. I have a background in astrophysics. I understand these equations, but there's pages and pages. It's like, this is going to take me a week to turn this into code. I handed it off to, I think ChatGPT was the first one. It took 5 minutes. And it gave me code that ran the first time. About 20 pages of code, 5 minutes. Now I found some bugs in it, and I had to, but I got a reasonable answer that I could, in a couple of days, fix it and make it right. That's where it's going. Why would I hire a room of 100 developers when I could hire 1 or 2 really experienced developers that could do the same amount of work and pay them 1/10 as much? And that's going to get even more so. Eventually it's just going to, I wouldn't even need the experienced programmers anymore. It just generates the code and it's right the first time. Now, one of the things that I do is I will have one LLM write my code, and I'll review it and make sure it looks reasonable. Then I'll hand it to another LLM and say, please code review this. And it'll come back and say, well, it's mostly right, but it's got this one edge case problem over here that if, in this edge case, and then I'll hand it to another LLM and say, well, it found this problem, and then I'll hand it back to the original one. And I'll run it through multiple iterations, and I'll have them write test suites for me, and by the time I'm done with this, I've got good code. Right. So, so I guess this is basically the end of the presentation. So we're going to have jobs lost and gained. Like I said, like the 300, going back 300 years in the time machine, I don't know what the jobs are going to be. Hopefully there will be jobs, but if there are, they're going to be so radically different from what we do today that we probably can't even understand what those jobs are. And so here's the end. So again, a link to, if you want to download this, there's some, in the handout, there's a glossary of terms. There's a link to some, I think they're all YouTube videos that will go deeper, if you want to go deeper into what is a neural network. And I said, you know, that neuron takes a bunch of inputs and does a weighted average, but there's more stuff going on. There's a lot to that. If you want to understand what's going on inside that neuron, it's not just weighted average. There's a video that talks about that, about deep learning neural networks, et cetera. There's a bunch of links in there if you want to get deeper into this. Okay, so that's...
Is the handout that you've given us on that techtalks.com, et cetera, handout there?
Yes. Yeah, so there's two handouts. One is a copy of my slides. The other one is a paper that just gives a glossary and some links to other things. The paper version is kind of hard to click those links, so you might want to download the digital version so you can click the links. Okay. All right.
Thank you. That was excellent. I think I speak for all of us when I say that was excellent. You know, reading news articles or something about AI. Events coming up next. Don't stop here. We have more. Tomorrow is Pie Night at Flying Saucer at 7 p.m. Tuesday, we're having ASF board meeting. That is on Discord. Instructions are available if you just RSVP to it on meetup.com. Then on Sunday, August 23rd at 2 p.m., we're having a book club meetup where we're going over Devil's Knot, the true story of the West Memphis Three. So even if you haven't read the book, and I'm plowing through it, I'm going to make it, I think. Try to attend that. It's a good start. And then that same night on next Sunday, we're having a meeting at La Huerta in Conway at 5 p.m. Good meetup for those of y'all who can make it to Conway. And then Fourth Monday Discord is that following Monday, August 24th. The book club has an additional event on Wednesday, August 25th, a special treat where we get to have an online chat with the author of Devil's Knot. If you ever wanted to talk to the author who explored that whole story and that whole saga, this is your opportunity. Brought to you by our wonderful volunteers. First Tuesday is going to be the first Tuesday of September, and that is September 1st. 5:30 p.m. at the usual place at the American Pie Pizza. Then Sunday, September 13th, the second Sunday of the month of September, is Second Sunday Cantina Communion. Followed by, on that Monday, the second Monday, Discord. So Discord is second Monday and fourth Monday. Then we have the second Sunday is Cantina Communion. Then we have a board meeting on September 15th, again, that you're welcome to attend, and another monthly meeting, same place here, on September 20th at 1 o'clock. Life after release from prison and homelessness. So if you want to hear about how the system drops people off after prison and how the prospects go after that, please attend. In the meantime, stay for snacks. We need to wipe those out and mingle and get to know somebody, because these are your free thinking neighbors, and always a great conversation here. Thanks everybody for coming.